Good morning, everybody. Today we're going to start coding. We're going to build an artificial intelligence library specifically designed for Arduino. We're going to start to do it with processing. So the first thing we have to do is open processing. On the start, I have to say that the basic of this code is based on Daniel Schiffman works. As you know, I'm taking a lot of the stuff I'm learning from him. We will add all the Arduino functionality, getting serial data and optimizing it to Arduino. So processing is working with tabs, and you have to remember it's a Java based platform. So we're going to open a new tab, and I'm going to call it nodes, and we're going to save it as smart robotics. So what I want to do is create a class that will enable us to start using artificial intelligence. So just follow along, and if you have any question you can post them later. So we will start a class, we will call it nodes, and let's have some space here. And for started we need 3 variables, I think. First we need the learning rate. I will explain every variables as we use it. So we will say learning rate. We need the number of nodes that we want, and we will need the weights. So we will start an array with, let's say, 10 elements for started. We can write here like whatever we want, and we are able to use some of them or not use some of them. So this is like very flexible way to start an array in Java. Then we have to start the constructor. So the constructor is, the syntax is as follows. We're gonna say int and float, no, the opposite, float lr and int nodes and here we can set int. And why do we have error? Yes, okay. So now we're gonna say this dot lr equal lr, and this dot nodes equal nodes. So this is a way to in processing that it enables us, it's really similar to JavaScript, that if we open many instances, it knows exactly what we mean. And here we have to have a capital, so it's the same. Now we have to initialize the weights. So we're gonna say for int I equals 0, I is smaller than this dot nodes I, and we're gonna say weights I equal random There are many ways to initialize the weights. For now we're gonna just use a random number. It's all science of how to initialize the weight, but for now this is enough for us. So for now we have the basic structure, but we're not doing anything with it yet. So let's say like this. We want results. We want the model to give us results. So we will say, and we want to accept an array, array of inputs, because we have inputs that will come from the Arduino. So we will say float r and now we say you have to return we have to return a number, but we're not there yet. So what we want to do is initialize a variable that will sum the result, and we want the output, so the output, we'll call it output. And now we're going to say for int I is smaller than this that nodes. As you see, we have a lot of for loops here, and what we want to say is sum is equal sum is equal to what? To r dot I times weights I. And we want to, I want to print the result, so I will be able to see them. But first what we have to do is, okay, what I want to have now is a result of 1 or minus 1. So we will create a function that we will call it, we will say output equal bool sum. So we don't have a function like this, so let's write it, and the function will go like this. What I want to do is that whatever number I get, if it's greater than 0, then we will get a 1, and if it's less than 0, we'll get minus 1. So we will say int bool, and we will accept float data, and we will say if data is greater than 0, return 1, else return minus 1. Very simple. And now what we have to say is just return output, and we finish this function. So you can see it's not a lot of code, and we're almost finished, because in this function we will get a result, and now we just have to train the model. And how we're going to do that? We're going to say void train model, and we're gonna accept inputs as an array and a target, which will be an integer, because we're gonna have 1 or minus 1. So what we have to do here, first of all, we have this function that will give us the result. So let's use this, and we will say equal what we're going to say is res inputs, yes. So we have that, and we want to initialize an error, but first we're going to say int how we're going to call that, no, this we will call prediction, and this we will call result, and we're going to say result is target minus prediction. And not result, error, the error, because yes, this will be the error, because what's the distance between the prediction that we have to the target is the error, and according to that we want the model to move towards. So because the way the model is working, we have a prediction. We tell the model, here is a bunch of input, give us a prediction. Then when we train it, we tell him, this is called supervised learning. We give him, okay, this is the result, we want you to go towards that result. And then we calculate the error. The error is the distance between what the model is currently thinking that the result is and the actual result. And now after we have that, we can calculate what will be what the weights are need to move towards to, because remember the input is connected to the hidden with weights, and hidden is connected to the outputs with weights. So now what we have to do is calculate the weights. So for that we need another for loop for int I equals 0, I is less than this that nodes, and now we're gonna say weights I equal and what they're equal to is inputs I times the error times the learning rate. So why we're using the learning rate? Because we don't want the model to move too fast, because if we have a certain distance and the model will make big step, it will overshoot the target, and then we will never get the result, it will just bounce. So we set the learning rate to the number that suits us. What I want to do also is that we will be able to change the learning rate according to the stages of the training, but this we will do later. And some or other, I always forget the S here. Now we have finished, and the last thing we have to do is say error equals 0. We're gonna want to, although we don't have to do that, as I see. So for now, this is for today, and because I don't want the videos to be too long, because as I see people don't like videos to be too long. So in the next video we're going to start testing this class, see if it's working, and add some arduino functionalities. So I'll see you next time. I hope you enjoy, and have a great day.